Having found the probability that x is equal to 6 and the probability that x is less than or equal to 6, let's find the probability that x is bigger than 6. This is the opposite of the case that x is less than or equal to 6, so we can use the complement rule and the binomial CDF command to find that this probability is 0.7759 or 77.59%. To find the probability that x is less than 6 without the equality, remember that we don't want to include 6, so only the numbers up to 5 count. So we can think of the probability of less than 6 nurses leaving as the probability that 5 or fewer leave. Using the binomial CDF command, we get that this probability is 7.81%. How about the probability that x is between 4 and 9? Notice the notation here. Neither inequality has an equal to, so we are not including 4 or 9. If we look at the table we've seen before, we can get the probability we want by adding the probabilities of getting exactly 5, exactly 6, exactly 7, and exactly 8. How can we do that with the calculator? Well, recall that the binomial CDF command gives us the probability of less than or equal to the number we input. So let's look at the probability of less than or equal to 8. It's overcounting. Specifically, it's overcounting the probabilities of 0, 1, 2, 3, and 4. If we subtract those, we will adjust for the overcounting. But we can get the probability of those using the binomial CDF command. It's the probability of less than or equal to 4. So we want the probability that x is less than or equal to 8 minus the probability that x is less than or equal to 4. Using the respective binomial CDF commands, we find that the probability is 73.62%. Here are some problems for you to try. What is the probability that more than 8 nurses leave in the first year? What is the probability that between 6 and 9 leave? Notice the notation. This time we are including the values of 6 and 9.